Section 11.5 is volumes of prisms and cylinders. So the volume of the solid is the number of cubic units contained in its interior. It is measured in cubic units. So the first one we'll see is the prism. So a volume of a prism, the volume V of a prism is V is equal to capital B times H, where capital B is the area of the base and H is the height. All right. So now what you should notice here is if I have one that's straight up and down and one that is slanted, again, the volume will still be the same. And the easiest way to think about it is think about a roll of quarters. If you have a bunch of quarters and you just kind of push them so that they're slightly tilted, the volume doesn't change, just the way that they look changed. So, and that's called a Cavalieri's principle, which allows you to state that. So that's a pretty important principle. So example one, find the volume of each prism. So A, remember it's the volume is equal to capital B times the height. So now on this one here, what is your base? Now remember the base is the one that has the same figure and when it is and they're parallel to each other. So if you look here, we have a triangle here at the front and we have one here at the back. So that would be our base on this one here. So the base would be, again, what is the formula for a triangle? Well, it's 1/2 the base times the height, and that would be the little base. So again, on this one here, our base would be 5, and our height would be 8. And if I work those out, I'll find out that that is 20. All right. So then our V is our capital B times our H, which will be 20 times 3. And remember, volume, I just told you, is always in cubic units. So that would be, in this case, 60 centimeters cubed. All right, so the biggest thing right here is to make sure you know what the base is. All right, so for example, on this one here, our base is right here, and it looks like it's going to be a trapezoid. All right, so again, I'm still going to use V is equal to capital B times H. In this case, my B is, remember, it's going to be 1/2 times the height, which would be 2.5, plus the bases. So one of the bases is 4.4. Okay. And I said plus, so let me fix that. 5.6. And that'll equal 12.5. So our volume will be our capital B, which is 12.5. And our height for this one, again, the height would be the one in between the two. So that's why right here our height was 3. It wasn't the H for the other one, same as here. It's not the 2.5. It's the one that's in between the two parallel figures. So that would be 4.2. And when you work that out, you'll get 52.5. And again, cubic centimeters or centimeters cubed, however you want to say that. Okay. Volume's basically the same thing, except on this one here, your base is, again, it's a circle, so it's the area of the circle. So the volume V of the cylinder is V is equal to capital B times H, where, again, I just told you the B is equal to pi r squared. And H is the height, and R is the radius of the base. So example 2, find the volume of each cylinder. Same kind of thing. Remember, it can be slanted. You just have to take the height. So again, I'll go ahead and go V is equal to B times H. In this case here, our B is equal to pi r squared times H. And let's see, our R in this case is 5 squared. times our h, which is 9.1, which will equal, and again, look and see if it says exact or if it's approximate. If they ask you to leave it in terms of pi, on this one here, you would have 227.5 pi. That would be your exact answer. If they tell you to round it to something, remember, use the pi, the full thing, and when you're done multiplying it all together, then you would round it, and you would find it would be approximately 714.71. And again, even here, volume is always cubed. For the second one here, again, B is equal to capital B times H, where again, B is the base, the area. So in this case, it would be pi times our R on this one here would be 7 squared times our height, which would be 22. And again, if same kind of thing, if I'm going to take it and leave it in terms of pi, I'll get 1878 pi. That's exact. If they ask me to round it to the nearest hundredth, 3,386.64 cubic feet. All right. Now, every once in a while, they'll go ahead and give you the volume and have you look at other things. All right. So I have a couple examples like that. Example 4, you are building a cylindrical packing tube, and you want the length to be 30 inches and the volume to be 589 cubic inches. What should the radius of the base be? So again, remember, our volume is equal to our capital B times H, while our capital B here is pi r squared times H, which is our volume. And now let's plug in everything and see what we need to do. So let's see, they told me the volume is 589 cubic inches. We have pi. I don't think in this one, we don't know what r squared is, or r, and we know that the height, or the length of it, is 30 inches. Okay. So if I take that, then what I can do is I can take and divide both sides by 30 pi. So if I do that, then I'll get r squared is equal to 589 divided by 30 pi. And to get r by itself, again, how do I do a square? I square root it. So I'm going to take everything and put it under the square root symbol. Again, it depends. Sometimes it makes more sense to put it in parentheses there for you. And if you plug that into your calculator exactly the way I have it, it will tell you that your radius is 2.5. And remember, that's going to be in inches here. And since r is linear, we're just going to say it's inches. Okay. Example 5, you are building a 3-foot tall dresser. You want the volume to be 42 cubic feet. What should the area of the base be? And give a possible length and width. So on this one here, again, I just found a picture of all this, the one they had in the book. Definitely looks like it could be taller than 3 feet, but I just went ahead and used it. So volume is equal to, again, capital B times H, where B is our area of the base. So there's our base right there. Remember, we have another one on top, but it's the same thing. So I can say that 42 feet is equal to our base, which we don't know what it is, times our height, which in this case is 3. So to get B by itself, I'm going to divide both sides by 3. And when I do that, I'll get 14. So now it's saying give a possible length and width. So remember, our base is going to equal our length times width. So even in your textbook, it has one that's kind of like this. On this one right here, the only one that really makes sense is to make one of them 7 feet and one of them 2 feet, all right? So we could say length of 7 feet and a width of 2 feet. I'm sorry, I should have put word width there. I mean, you could have came up with ones with decimals on it. You could have used 14 feet and 1 feet. Okay. Again, that's what they're going to have you do on some of the homework. And finally, a composite solid consists of 2 or more solids. You can add the solids, like when they're stacked, or you can subtract them. For example, let's say that this square here had a circle in it, had a hole drilled in it, then I would subtract it once. But since it's the one on the test was a composite one like this, and I gave you a couple like this on the homework. So this is the one that I chose. But again, remember, if there's a hole in it, you would be subtracting the volume of that from the volume of the stuff that you have that is solid. So on this one here, what I did is I called one of them V1. So if you look at it, you have a half of a circle or a semicircle or half of a cylinder, right? And then you have that on top of a square. So I named the top one V1, and then I named the bottom one V2, all right? So we know that our V total will equal V sub 1 plus V sub 2. So the volume of the first one, again, that would be a semicircle. So that means I would take half of the area of the circle. Remember, the half of the circle is pi r squared times h. Well, that's our b, right? And then I would have, pi r squared. That's my b times h. But in this case, I'm going to either take all of that and divide it by 2 or multiply it by 1/2. So on this one here, I will have 1/2 times pi times our r. Remember, the whole thing there, the whole diameter there would be 5. So we know our radius would be 2.5. So I'm going to take times 2.5 squared times h, which our h is this one right here. This one right here. So that would also be 5. So if I work that out, my V1 is equal to, I came up with 49.09 feet cubed. All right, my V2 is the volume of that square. So again, the base would be 5 times 5. Well, let's go ahead and do it right. So it would be capital B times H, where our B would be 5 times 5. But in this case, our H is also 5. The one on the homework is very similar. I think it's 4s. All right. So if I work that one out, I'll get 125 cubic feet. So then our total, V sub t, will equal our V sub 1, which is 49.09, and our 125. And if you look at that, you get 174.09 cubic feet. Or if they asked it to the nearest whole number, you would say it's about 174 cubic feet. That's it. Okay. Thank you.